We're now starting Chapter 3, which deals with constructions in geometry. Today we're going to talk about Section 3.1, which is going to do duplicating segments and duplicating angles. When we work with constructions, we work with a compass, which looks something like this, and a straight edge, which would be like a ruler where we're not looking at any of the measurements on the ruler. The first thing we have to deal with are some directions that the book uses. Sometimes they say sketch. When they say sketch, it's a freehand sketch, and you only need a pencil. So an example of sketching an equilateral triangle would be to draw three sides that kind of appear to be equal, and then to make sure that everybody knows they're equal, you would put tick marks on them. So nice and fast and easy, that is a sketch. When they say draw, it's a little bit more complicated. It has to all be measured and precise using a protractor and a ruler. So for instance, here I might take a ruler and draw a 5-inch line, and then I know that in an equilateral triangle, every angle is 60 degrees. So if I move my protractor over into the corner here and create a 60-degree angle, and then make the side of that angle 5 inches long, just like the other side was here with my ruler, then I could complete this by connecting those sides. So drawing is a little bit more time-consuming and a little bit more complicated than sketching. When you construct, it's precise, but there really are no measurements. You need a compass and a straight edge. So if I had to construct an equilateral triangle, I would draw my first side with a ruler. You're going to learn this later in the lesson also. You're going to stab in at one of the endpoints and create an arc, and with the same opening, stab in at the other endpoint and make an arc. And then you're going to connect that intersection point to both of the endpoints, and that would be constructing. Of course, you'd be using a ruler. I can't really use a ruler on my tablet, so my lines are never really that straight. They also say sometimes in the book, use patty paper constructions. We usually avoid these, except if we're doing an investigation. What you need is just paper that you can see through, like tracing paper, or actually loose leaf paper is thin enough that you can see through it. But again, we're not going to use that too often. When they say use a patty paper construction in homework, usually I'll just say to you, no, use your compass and straight edge instead. So the first construction we're going to do now in geometry is duplicating a segment. So that segment is AB. I always have the directions for the constructions, so I'll go through the directions first and then I'll show you how to do it. Draw a segment longer than you need with an endpoint A prime. Open your compass as wide as the given segment AB is, that was given to you originally, and then with that same compass opening, place your compass point at A prime, swing an arc through the new segment, creating a second endpoint, and label it B prime. So now I'm going to see if I can actually show that to you. Okay, so I'm going to go down here and I see my ruler and my compass. So let's say that this is my line segment AB. I draw a segment that is longer than AB. The second step says to open up your compass as wide as the original segment AB was, stab in at the A prime point, and swing an arc through here, which would be B prime. So this segment AB has now been copied over here to be A prime, B prime. Okay, I also have a slide here that says if you want to see somebody else duplicating a segment, you can copy and paste this link into your browser, or you could click on it. And you could also go to my CMH, Accelerated Geometry Links, Chapter 3, Constructing a Duplicate Segment. So you will see me do it, and then now you can see somebody else do it. So you'll see two people do this construction. Next is going to be duplicating an angle. So the directions come first. So I'll just have these here, and then I'll go through it on my own, but I'm just showing you that there are 4 steps to this construction. And now I'm going to again try to get rid of this, and I'm going to go to the place where I can actually draw something. Okay, so now I will take my pencil and I will construct, just by drawing it here, an angle A. Okay, now I want to copy it. So the first step is I'm going to copy this ray that goes across here. So I'll go down here and I'll say, okay, there it is. Okay, I'll even call it A prime. Okay, next, this angle is open different openings. See how if I'm over here, the opening between the two sides is very small? If I zoom out a little bit here, now the opening is a little bit wider. If I go out here, it's even wider yet. So what I have to do is determine in my head, where do I want to do this measuring from? So I'm going to stab in at A and open up my compass about this big, and I'm going to draw an arc across. So that is saying, okay, that's how far I'm going to be from the vertex A. At that distance, I'm going to be able to measure this opening over here. So I come back over to where I'm duplicating and I stab in at A prime, just like I stabbed in at A to create that arc. I'm now stabbing in at A prime and creating another arc. Okay, those arcs are both the same distance from their vertex points. Now I go back to A and I say, hey, that far away from A, that's how wide the opening is on that angle. So if I stabbed in here, I could make a little arc to say, hey, that's how far the opening is going to be. That's where the second side has to occur. So I do the same thing here. So if I call this B, for instance, let's do it nicer. If I call this B and this C, okay, now I stab in at B to figure out how wide it's open. Now I'll stab in at B prime, and that's how wide the angle has to be open. So that is going to be my C prime. So my last step is just to connect the vertex to that arc intersection, and I have now duplicated angle A. Okay, now I'm going to go back to the presentation, and those are the end of the 4 steps there. Okay, I will say over here that you can also see somebody else duplicating an angle. So you could copy and paste this link or click on this link or go to my CMH Accelerated Geometry Links, Chapter 3, Constructing a Duplicate Angle. Okay, now the next problem that we have here is going to be a problem dealing with copying segments. So it says, use the segments above to construct a line segment with length 2AB plus EF minus CD. Okay, I'm going to put that down and come up to my camera here. So I'm going to, on the top here, do an AB, and CD is a little bit smaller, and EF is even a little bit smaller yet. Okay, so I'm going to draw a line longer than I need, and my first step is I need 2 ABs. So I'm going to open up my compass as wide as AB is, stab in at the end here, and there's 1 AB. If I put my compass at the end of where I just put that arc, there's 2 ABs. Now I want to add an EF to that. So here's my EF. I open it up that wide. There's my EF added on to my 2 ABs. And now I want to subtract CD. So I open up my compass as wide as CD. And now I want to subtract it. So I'm going to put my point at the very end of my 2AB plus EF, and I'm going to go across there and say, if I subtract off that CD now from my 2ABs plus EF, my answer is going to be this. So from here to here was AB, from here to here was an AB, from here to here was an EF, and then from here to here was my CD that I chopped off. So this is 2ABs plus an EF minus a CD. Okay, next problem. It says to draw two acute angles on your paper and then construct a third angle that is a measure equal to the sum of those two. So again, I will bring this down and I will draw two angles. So I'll make one really skinny and I'll make one a little bit bigger. Okay, now here I want the sum of those two. So I'm going to stab in at the vertex and I'm going to say this is how far away from the vertex I'm going to measure. Same distance away from the vertex in the littler angle, and over here same distance from the vertex. So I'm going to go way beyond there, even farther than I think I need. Okay, then I'm going to go back. I'm going to say how wide is this guy open? That's how wide the first angle is going to be. Now this is not my answer, this is just the first one, so I'll put it in on a dotted line. So there was my first angle. And I'm going to add on to that the second angle. So I put my compass where I ended up the other one, and there is my second angle. And so therefore that's going to be the addition of those two angles. Okay, back to the presentation. And I will go over here. So this is how to construct that equilateral triangle that we did in the very beginning. Here are the steps for doing that. Here is also a place where you can link to see somebody else do it besides me. And in the meantime, I will show you the construction. So if I go back to my drawing area here, okay, I want to do an equilateral triangle. I'll do it down here. Okay, my first side, let's say, is that long. Now, I know all three sides of an equilateral triangle are the same length, so I'm going to open up my compass as long as that first side. That means the second side has to be that long, starting at the end point on the left, and then there's a side starting here at the end point on the right that also has to be that long. So the place where both of those lengths are going to work out to be the correct length would be up there. So I connect now from the arc intersection to the ends of that segment, and I have an equilateral triangle. Okay, here again is a place where you can go to see another one of those constructions. And then I think the last says there is some homework associated with this. So that is the end of this presentation for today.